Okay, so today we will have measure phase tools and the make framework. We will cover some tools. Some of them maybe it was covered in the review, but today also we will focus them in a different way. And along the other phases, you will see more additional tools to the one that covers in the Six Sigma review videos. We will start in the measure phase with the histograms. What is the histograms? Why we use it? When we use it? How important is the histogram? I will give you an example first to think about it before we go to the definition. If I have now 120 students in a class, and I have their grades, and their grades are distributed from A plus until F, and there is a DN denied from the class. So we have A plus A, B plus B, and so on. If I'm going to look to their grades individually, it will be hard for me to identify what is the largest amount of students who scored A or B or within a range of A, B, how many students they failed the class, what is the mean or how is the distribution of their grades. This is all can be simplified using histogram. There are other tools like you can calculate the statistical measures, average, mean, max, and min, and so on. But the histogram gives you a simple visual representation for this large amount of data in a way that you can answer all these questions that I was stating about that example easily by just looking to the graph. So that's why the histogram, it is important. And usually when you collect data in the measure phase, it would be easier sometimes if you have a large data to use histogram, so represent it and represent the recording of those values. It is a bar chart of numerical variables, giving the graphical representation how the data are distributed. And the main advantage of the histogram is to use to represent large data and also to identify and underline the distribution as well as the central tendency. That's mean also you can identify the average and how the mean looks like in this set of data. An example here was given. This is from a class that I have taught last year, GE 405, Engineering Economy for College of Engineering. And those grades were achieved by the students. If I was going to look to these grades, imagine, compare the look here in the table, how their values, how the total marks, compared to the graphical representation of the histogram. The histogram here, I can easily see that the majority of the students, first, they pass the class. The majority of grades placed between the D plus and B plus, I have from A and A plus, also above B plus, let's say, from B plus to A plus, since the 85 it falls in the B plus, I have from B plus until A plus a good number of students. That means they are achieving high scores compared to number of failed students who are scored in low scores or low marks. Here we still consider that we have some they could pass because they could score 60 to 65. By just looking to this picture, I can tell and give all this information. Also, I can categorize them based on the grades, A, B, A plus, C, and I see the frequency of each one or each group of them. I looked usually to histogram of my student scores every year and see where is the majority, how is the percentage or the frequency of passing the course compared to the failing the course. how many or the percentage of students they are scoring high, which means excellence students in the course, and also the low grades. All these, I could easily get them and extract them from here compared to the student marks, just numbers as it shows here in the table. Also, I can see the distribution, how it looks like. This is, okay, close to normal distribution, a little bit skewed to the right, and it is commonly you see it in example like that for grades, because grades are expecting to have above 60 of the majority of students, since 60 is the passing grade. So students are scoring less than 60 is going to be usually few. So that's why it is usually a bit moving to the right or skewed to the right, but it's clearly that a normal distribution can easily applied here. So all this information, I could find it easily by just looking to a histogram graph. Another tool that is similar to the histogram, and I intentionally added this tool here in this sequence, which is the Pareto analysis. The Pareto analysis uses the same concept of bar chart, but the way how it is represented, it is different. The way how you look into the data and interpret it, it is different. The bar chart use ranking the orders for the bars from highest to the lowest in terms of the order. And why it's called then Pareto and not just a histogram with ordering from highest to lowest, basically because the Pareto concept was initially found by Italian economist Wilfredo Pareto, who observed that 80% of the effects are caused by 20% of the causes, and this they call it 80-20 rule. What does it mean? Means that if you, let's take an example. If I'm going to collect the students' complaints at the end of the class, and I ask them what was the causes of their complaints, why they are complaining about a class. And I categorize the data collected based on, first, the complaints was because the instructor was not good, like me, or maybe the course material was not good, or the third category maybe is the exams or the assessments in general was not fair, and others, maybe the lecture time or the lecture length or so on. So those the major three complaints were coming from. The 80-20 rule says that if you focus on the 20% of those causes that I listed them, you will resolve 80% of their complaints. So if the majority, or let's say the majority of the students, or the 20% counts of the complaints were applied on the instructor, then focusing on the instructor will resolve the majority of the complaints. If the 20% of the counts were, let's say, splitted between the instructor and the exams or the assessment, then focusing on those two will resolve the majority of the complaints. By focusing only on 20% of the causes, will resolve 80% of the effects. That is the Pareto rule, what it says. It is using the histogram again, or bar chart, but in a different manner or a different representation, and prioritize the problem of any nature, as we were talking here about course complaints or students complaining about course. It could be applied also in machines, failure, or any other applications. Also, in addition to the Pareto rule, there is an extra implementation to graphically or visually represent those percentages. It used the ABC analysis and is not mainly required to do the ABC analysis, but sometimes it just to make things easier when it represented and how you see the graph, as we will see in the examples. The ABC analysis, basically, it demonstrates those 20% needed first from the causes as a clustered or category A, and the percentage of the categories that above the 80% of the effect to 96, they consider that as a B items or B cluster, and the remaining is C. So they look to the effect percentage first until you achieve the 80%, which is either 20% of one cause or multiple causes, and they cluster these as a category A, and then the above 80 to 96, they cluster them as B, and the remaining as C. The x-axis is in all Pareto charts is representing the causes and the value of causes. The y chart representing the effects and also the number of counts. The number of counts for those, let's say, students who complain about the instructor is in the y-axis, and also the y-axis, as we will see in the example, represent the percentage of the effect, the cumulative one. The ABC only adds this clustering, which is the ABC, to demonstrate the 80% of the effects, in addition to the 80 plus additional to the 80 to 96, and the remaining in different clusters. If you would like to use this type of clustering, which is the ABC analysis, there is a link here. It shows you step by step how you can do it on Excel. Minitab use usually the regular Pareto analysis, as we will see here in the example. This example shows or applied using Minitab. In this example, we are demonstrating customer complaints about a service, or let's say delivery service. The frequency and how it is ordered, this is the unique about the histogram. You see the largest complaints or the largest number of complaints come first, and then the least in the category, and so on gradually until the last type of category from the causes. The causes of their complaints about the delivery or about the service, it was categorized based on here in the x-axis. The first category was because of the documents, and the second category was the product quality. The third was the packaging. The fourth was the delay, and then there is other reasons for or causes of the complaints. So the effect is customer complaints. العميل غير راضي. So the customer complaints collected, and the frequency of their complaints, 40 was for the documents, 32 for the product quality, 11 for packaging, 7 for delivery, 4 for others. Looking to this table also will help you easily to identify that documents representing is the highest frequency of the causes that affecting the customer satisfaction. So you should have focused on this one first in order to investigate more what was the causes of the documents, what is in the documents that makes the customer complaints. Maybe the document's very long, maybe it was not clear, the information, the instruction is not clear. You have to investigate in the analyze phase and identify why the documents need to be emphasized more or focused on more. When you draw the Pareto, first, when you do the Minitab, I will try to zoom in a little bit so you can see. This is the Minitab screen. In the Minitab screen, you go to Stat, and then you select Quality Tools, and it will open all the tools for this, quality. The second one is the Pareto Chart. When you press to that one, and it will open to you a window like this one here. This window will ask you to enter the data of the frequency as well as the attribute data, which means that the categories or the customer complaints or the causes in general, what are the causes that for this problem. In this case, the customer attributes or defect was stored on the C1 column in the same manner here. Customer complaints first, then documents, you type them on the Minitab worksheet. And then the frequency, which is placed here with the same order, was written on the column C2. So you press here and double click on the customer complaints or customer complaints, double click here, so it will appear on this field. The same here, when you enter to this field, it is empty like this one here. It will show you all the columns information on this box. When you go to the frequency, you double click it and it will appear here. That means it will collect the data from that column, which is column C2 or the frequency. Then you just press OK and leave everything as is. When you press OK, the Pareto chart will pop and appear to you. The frequency is listed here as in the table, and the percentage of the occurrence of that frequency also it is appeared in the second column. The cumulative percentage, and here where you can find the 20% of the causes, it is in the third row. And if you look to this example, 42% is already on the document category, or in the document cause, or the causes of the document represent 42.6% of the causes. That means if you deal with the document here and you focus on first, you will resolve 80% of the effect of the of that problem. It doesn't mean that you don't focus on the remaining if you can, but sometimes depend on the case you are dealing with, or how depth you need to go inside each category, how much cost will cost you, or time it's needed to investigate in each category. So if you are facing limited time or limited resources, or you want just to focus on the major criteria here or the major causes, in this case 42 is already more than the 20% that is caused by the documents and was the reason for the 80% or more from the customer complaints. And that's why focusing here, it will resolve the majority of the problem. Now, in sometimes you may think, if I count the remaining numbers of the counts is less than or larger than the 80%, if I count the, for example, the 40 here, it could be less or it could be more than the 80%. The Pareto is assuming that when you resolve the 20% of the causes, it will resolve 80%, but doesn't have to be exactly with the 80%. It could be less or more. There is a variation, depend on how many categories you have, how many frequencies appeared for each one of the categories, the variation between the frequency in each category. So sometimes, for example, here, if we focus on the first two, that means you are covering more than definitely the 80%. But also focusing on one of them, that means you are focusing on 42%. And if you look to the percentage here, that's 42. It is high enough. If you eliminate it, to reduce the customer compliance significantly. This is how you prioritize. And again, I'm not saying that you neglect the other categories or the other causes. Pareto is not meant for that. If you look to the definition here, is you to prioritize the problems. Prioritize it means أولويات. Which one should I focus first? Okay. So this was an example for the Pareto. There is another example here, applying the ABC analysis. The example is talking regarding to the manufacturing of integrated circuits boards, and the defects happen during that process. The categories or the causes for that defects comes from different causes, molding, cracking, others of other causes that cause the defects in the circuit boards. When you all apply the ABC analysis here, it will give you this graphical representation for the causes, 20% of the causes and 80% of the effects. If so, that's mean if you resolve 20% of those causes, that you will resolve 80% of the effects. In this case, that's mean if you focus here on this area, and sometimes it will enter, or maybe it will be on two causes, like for example here, etching and soldering, they will be on the 20% rule. And that's mean to get the 80%, you will need to focus on those two. But again, if you would like to prioritize, you will focus here on this cause first, and then you move on, as well as we did here. If you would like to achieve the 80%, you may go to this level here, which will include the product quality with the documents. But 42% of the documents, it will be fair enough to reduce a 40 here of those frequency of compliance, and they are coming from one category. Sometimes to achieve the 80% here, it comes from either one category or several categories. And then it will come for you, the decision and the management and all, as we said, the resources and the time you have, whether to focus on the documents, product quality to come to that level, or if you focus on the first one, you will resolve a good enough portion of the complaints, because here the documents in this case is causing a lot of complaints. Also here, if you think about it, the causes for the first category or first area, it is showing that a large number of causes. And if you don't have the time to prioritize, or you need to prioritize, so focusing on the first one would resolve the majority. But if you would like to stick to the 80-20, then include the second cause here to resolve 80% of the effect by using 20% of the causes. So again, to summarize, 80-20 rule, stating that focusing on 20% of the causes to resolve 80% of the effects or the complaints or the problem you have. But doesn't mean that you neglect all the other causes. And also, if the causes are coming from one or more than one criteria, then it is up to you on the situation you have to prioritize. If you have the enough resources and time, then you can apply and use all those categories to resolve 80%. All the categories causes the 20% of the categories to resolve 80% of the effects, or you take the first one if you don't have the enough resources and enough time, and maybe you leave that in the next step or in the next project. As we said, it will be depend on the complexity of the project, the time limitation, the resources you have, because each one of those here, it needs more investigation in the analyze phase, and you have to dig inside and see what is the root causes for those problems. Usually here, your coach in the project, you have to consult him along with the stakeholders of the project and the sponsors to decide about where you will focus, whether the first one or you will cover 80-20, or maybe you have enough to cover all the other criteria. Okay. Moving on to additional tool in the measure phase, which is the cause and effect diagram. Cause and effect diagram is very important, and sometimes you see it in measure or analyze phase, and it is okay, but you don't see it in improve or control, definitely. That's some tools, you see it appear in some phases, but it is really rare or hard to see them or impossible to see them in other also phases. Like for example, here you don't see it in define phase, maybe, or definitely improve or control. You don't see cause and effect diagram, but you commonly see it in measure and analyze. What is the difference between cause and effect, Pareto, histogram? Cause and effect diagram give you the overall picture about the causes. Both of them in Pareto and cause and effect diagram, it deals with the effect and causes. For example, here in the Pareto, we have the effect, which is the customer compliance, and the causes, and prioritize them and see the frequency of each one of them. But in the cause and effect diagram, it shows you how many causes you have, how they are interrelated to each other. Sometimes you have sub-causes under the major cause for the same effect. And that's why cause and effect diagram, it's another graphical representation to show you the overall picture, so you can use it for brainstorming and decide about the Pareto later when you collect the data from the compliance, like for example we had in the previous example, or for the causes for those defects that coming, and you prioritize your next move. In the cause and effect, you just collect all the type of causes and you demonstrate them graphically using a cause and effect diagram. They call it also Ishikawa, referred to the person who started this diagram. Also, they call it fishbone diagram. Fishbone diagram because it looks like the skeletal, if you look at it, skeletal of the fish. And usually it is a quality improvement tools that's mean used for to improve. Is not to be used in the improvement phase, but it's used for improving. The effect is a specific problem and considered to constitute the head of the diagram, and then the remaining causes and sub-causes come in the bone structure, as we will see here in the example. Before we move on to the example, it is commonly that there are categories of the causes, regardless of the case study or the project you are dealing with. Now, you would like to use different name of those categories, it's fine. You want to name your own category for the causes, it is also fine. But from trials and implementation of the Six Sigma, they agreed on number of causes or common type of causes, and they called them 6M. And they are easily to be recalled and easily to be used. The 6M referring to machine, manpower, material, method, measurement, mother nature referring to the environment. Machine, if you have equipments, are causing the problem. Manpower, if the human being or human power you have in the organization or the process are causing the problem. Material, obvious, what is it? Method, now if you have a system, the process itself, if there is a software that used, it's causing the problem. The policy and the procedure. Measurements, that the data collected or the data measures are not accurate and it's causing the problem. Mother nature or environment, sometimes the weather or condition of the place where you are working, all these could be causes for the problem. Now, maybe the question students ask, or you may ask, should I use all of these categories? It depends on your case. Maybe your case apply or applicable to only 2 or 3 of them. Maybe your case applied or applicable to 2 of them or all of them. Depend on your project and depend on your case. Those are the most common. I will see you here an example that are not using all the 6M. Before we go and explain the example in details, you can see here the methods and measurements are empty. And this is okay, depend on the project. Now, this example is talking about the lost control of the car and what is the causes for the lost control of a car. And the data collected in this case or this example shows that these are the causes here: a flat tire, a slippery road, machine failure, driver error. Why we said that cause and effect sometimes comes here or sometimes in the analyze, those it could be at this level identified here, and the sub items or sub causes, it could be identified in the analyze. And Pareto here, maybe you did it in the measure phase only using those categories, which representing manpower, material, machine, environment. And you could maybe done here the Pareto and find out which one you should have focused first and how many causes that accumulate to 20%, and then you focus on them if you would like to achieve the or handle the 80% of the effect. That's why here you see the Pareto, it investigate more, and also for those subcategories, it can show other branches. For example, training. This is one of the causes for lost control of the car. If we investigate more about the poor training, maybe the school was not providing enough hours for practical training. Maybe the instructors in the driving school were not helpful enough, or maybe the time, the duration for the whole training program is not enough. So here maybe you could have another sub branches for the poor training, but in this case was not applicable. Now it depends on your case. So in the Minitab, first when you open the Minitab, you go to Stat and then select Quality Tools, and then there is Cause and Effect Diagram. When you hit that one, it will open to you this table here or this box here to enter the data. Now the data is written on the worksheet as you see it here in this picture. The first column, C1, was named or titled as flat tire, and then all the sub causes for the flat tires were listed in that column. The second column for the slippery road was in column C2, and then all the sub causes for the slippery road was listed here, and so on for the mechanical failure, driver error. So mechanical failure, we have a stuck accelerator, that's mean freeze on the accelerator and lost control. Brake failure, for example. Driver error, was for poor training, reckless, poor reflexes, and the condition of something happens in the road. When you enter those as you see them here in the worksheet, in the Minitab, and this open to you, you will press on this column here. Here is your entry in this one here, the causes. This one you just leave it as is for the default, and it says in column. What does it mean in column? That's mean all the information for this cause here, the first one, are listed in column. Which column? For example, here the driver error was here for C4. So when you come to this one, it will be blank like this one here. When you go and double click on that field, it will show and list all those columns from C1 to C4. It will be listed here. You just select the one you want to place it on the first row and double click on it here, and it will be appeared on the first row. Now regarding to the labels you will see them as you see them here with the same order, but you can double click on them and rename them, or you can leave them as is. This is depend on your case. So when you double click on the second row, it will open again the list of all the columns here, and you select mechanical failure column, which is C3, and double click on it here in this side, and it will appear automatically and feeds in this row. You apply to the remaining as you will see them, and you adjust those as you want. Here, to show you that you can use the driver error as a label. So instead of the manpower, I can use the driver error. But if you refer to the 6M, driver error come from a human mistake, which is related to the manpower. So it is related to the 6M. But there is no right or wrong if you would like to use manpower or driver error as a title for that cause. In case if I have sub-causes, as we were explaining for the poor training, then you will press on the sub here, and it will open the same window to you, and you have to have additional columns for poor training, and you list all the subs for the poor training, and you select them from here as you did for all these main causes. Each cause you enter the information, it will have the sub causes activated, and you can press on it if you would like to, and it will open to you the same window with the same manner. All what you need to have additional column that includes the information for the sub causes. Okay, now move on to machine failure. The label, but you can rename it and use machine by just double click. You can edit on the text and this inside the same box here, and it will show mechanical failure here instead of the machine. You can try it your own at home. Material and flat tire. The tire is part of the material you are using in the car, the most closest to it, which is the material, and that's why it's linked to. Slippery road, this is environment condition happen in the road, and that's why environment or mother nature, you can use it here as a part or as a category related to the 6M. So this was an example of cause and effect. When you press OK down here below this box, it will show you the same figure as you have it here. You can use these data and try it yourself and get the chart, and you can add and try to add sub-causes for one of those causes here, and try how you see the branches gets more. You will see more lines coming out of this one, and shows you the sub-causes for the poor training, for example. Moving on to another tool, I believe yes, the screen was here, not showing the complete picture. Just going back, the effect you can type here. What is the effect? So in this case, lost control of the car. You can type it, so it will appear here in the figure, as well as the title of the figure. In this case, I typed cause and effect diagram example, lost control of the car, and you will see it in the top of the figure automatically appear. So these entry, you can enter them based on the effect and based on the title you would like to use for your case study. Now, moving on to the another example for cause and effect, to show you that how sub-branches also, or how branches can appear, or causes appear. In this case, large international travel agencies, they sometimes that customers, when they go to the destination of their travel, the hotel, they don't know about the reservation. So imagine you are going with your family, you went to this travel agency, Minitab Siyaha, and you have done your package for the travel in the summer. You are going to spend in Europe, or maybe in Dubai, or wherever you have decided to go. You did all the booking, you have paid the package, including the hotel, the transportation, or whatever you have included in your package. And imagine you go there to the hotel, and the hotel doesn't know anything about your reservation. This example was talking about a similar problem that happens to many travel agencies. The customers, when they go to the destination, they don't know, they don't find the hotel, know about. That was the effect. That was the complaints from the customers who are the travel agencies collected from them, and they found most of customers, they are complaining about this issue, and they start to use cause and effect concept or diagram to demonstrate the causes. And in this case, they found all the 6M, since it is relative to the causes they have found. For example, manpower, the temporary staff, the staff are temporary in the hotel, so they are not communicating effectively with the travel agencies. Also, sometimes it could happen from the staff in the travel agencies, they haven't sent an email to the hotels, or vice versa, and it can come from different ways. And that's the reason why in the analyze phase you have to investigate more after you prioritize the cause you would like to, or maybe you will focus on all these causes. This is up to you and depend on the limitation and the resources you have for your case. Training and authority for the person to conduct that reservation in the hotel. This is manpower. Other, for example, the machine, for example, the computer reliability, that's mean whether to receive emails and checking the reservations that from the travel agencies or from the hotel side. So this is another example to show you how cause and effect diagram can apply in different cases and different from a production manufacturing problem into service industry, including all the type of sectors it can applying or it can apply the cause and effect diagram. Moving to two tools, I will give you the name for this one and the coming one. Run chart, control charts, because they are similar in terms of how they are represented, but they are different in terms of how they are constructed. So you have to identify here on this level what is the difference between run chart and control charts. Run chart, let's take it. What is the difference between run chart and control chart? Run chart doesn't have control limits, meaning that when we talk about control charts, we talk about control limits, upper and control upper control limits, lower control limits, center line. In the run chart, only you demonstrate the data over the time without any statistical calculations. There is no standard deviation in this case, okay? There is no formula. You just show the data as you measure them over the time using X and Y axis. So X axis for the X axis is for the time, and the Y axis is for the collected measures. The run chart has a wide range of application, and they use it to detect trends, variation, or cycles that happen for the process. Allow the team also to compare performance between measure and in the improve. So this tool, you can see it in the control phase. Why? Because in the control phase, you would like to see your improvement has done any significant changes from the previous status of the process. So in the measure phase, you will measure the current status, and in the control phase, you will use the run chart to see after the improvement how it's been changed. So you can put them next to each other and see how is the differences. So that's one of the other also applications of the run chart. It can be used for forecasting, so you can predict what is coming in the process, performance reporting, and breakdown. If there is a seasonal breakdowns that happens, also it can be clarified in the run chart. Okay, maybe the question isn't similar to the control chart. The control chart mainly focus on the stability of the process, and we will talk about it when we come to the control chart. But always some people, they confuse between the use of the run chart and when they use the control chart. And we will, when we summarize, after we finish the control charts, we will end up with a summary for both of them. Now, this is an example using a run chart in the Minitab. When you use run chart in Minitab, you go to Stat, and then Quality Tools, and then you use run chart, and then it will open to you a box for entering the Y-axis, which is the respond or measures, and the X-axis, which is usually the time. Now, whether you have time categories like month, years, minutes, hours, name it, quarters of the year, this is how you categorize or list the time in your X-axis. In this case, uses the month, and here is the operational efficiency percentage of packing machine example was. So these are representing percentage of the packing machine efficiency, and the run demonstration or illustration will be like that. J for January, February, March, April, and so on. It shows that here, where is the peak, where is the down, where is the average also of the efficiency of that packing machine over the year. Now, this is maybe around 1 year performance, so you can tell there are some months like August here, there is down operational efficiency. So you can, in the analyze phase, investigate more and find the reasons. Also, if this was applied in a control, then it will help you to go back and see what went wrong in that month. Also, it shows you the highest efficiency operational level, like in the months of October or July, and you can tell, or you can use those months as a best practice and also investigate what was the causes for this best practice, so you can convey it to the remaining month. Maybe it's a seasonal issue, like in August, due to summer, there are some issues, and then that's why the efficiency went slow. So this is how you can get use of the run chart. Moving on to the control chart. And the control chart, it is a large topic to be discussed, and it is already discussed in depth with all type of control charts and differences between them, whether variable control charts or control charts for attributes, examples, how you use Minitab to construct them, how to analyze them. All these information about the control charts, you can find them on the links here, starting with this link with the order to the second, third, fourth, fifth, sixth, and the seventh. With this order, you will cover all the information needed regarding to the control chart. If you watch those recorded sessions, it will give you a complete and comprehensive knowledge and practical practices how you conduct and analyze control charts. Control charts is similar in terms of the graphical representation comparing to the run chart, using the axis for individual measurement, such as mean or range, and also a vertical axis, both the horizontal and the vertical, to show that the data and shows you the control limits, and meaning that the control limits, the center line, lower control limits, and the upper control limits, and the points above the upper and lower control or below the lower control limits indicate that there is a special causes or an issue in the process. If there is no points, that common causes only appear. Also, there are other rules to investigate about the special causes are discussed in the recorded sessions here. And here to identify or distinguish between the control and the run chart. The control chart used for a process to make sure that it is stable or no. Or between common causes that normally happen or special causes where you need to investigate more about them and the causes behind them. Run chart does not do that. Run chart gives you an information about, in general, the variation of the cycle, detect trends, also helps for forecasting, also help for finding where is the breakdown, where is the best practices, downtime, which is also referred to cycles. As we saw here, also it shows you the average. It could for the performance, but it doesn't give you whether the process is stable or no. Doesn't give you control limits. In the control charts, we will see lines here for the control limits, where if there is any points exceeded those lines, that's mean out of control condition happens, and you have to eliminate it and investigate, run the chart, and see what the causes for those condition. Also, there are list of other special causes, identification, which is, they call it the Western Electric tools for or a handbook for identifying the special causes. All these differentiate the control chart from the run chart. So the control chart for stabilizing the process, make sure whether it's stable or not, to distinguish between common causes that appear in the process and special causes where investigation needed. The run chart does not have all these three advantages, okay, or two advantages. In this video, I would like to invite you to watch them and give you a detailed information about how control charts are conducted. This is an example you can use to draw a control chart, and here you can see that 99% or 99.7% of all the data fall within the control limits. This cannot be done in the run chart. Run chart does not have those limits, so you cannot say that whether the data or the process is majorly or commonly in control or stable or not. For example, there is a point out of control, it has to be eliminated, and you can investigate about what was the cause of that out of control point, and you run the chart to make sure whether it is stable now or not stable, as well as there is a point here that is below the lower control limits. The run chart does not do that. It shows you only the trends of the data. I hope that was informative enough for the measure phase. I will see you in the next session for the analyze phase tools.